Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to talk about Lasso regression algorithm. We are going to see what exactly it is. So in my previous video, we have already discussed about the ridge regression algorithm and as well as why do we use ridge and Lasso regression algorithm. So that part also we have discussed in the previous video. So I do recommend watching all the videos in sequence. So let's move ahead, but before moving ahead, you all can connect with me on LinkedIn and I will leave the link in the description box. Now, when we talk about the Lasso regression, right, of course I have written here the least, absolute, shrinkage and selection operator as the full name for the Lasso regression, but eventually Lasso regression is also used to prevent your overfitting situation. So when you talk about Lasso regression, it is almost same as your ridge regression. So if you can see the formula that I have put over here for the Lasso regression, right? So it is nothing but if you see this the first particular part, right? It is nothing but it is the cost function, right? It is nothing but the cost function that we have. And then if you see over here, you have lambda and summation of I to m and modulus of beta j, right? Now this is exactly same thing that we have seen in the ridge, but instead over there we had a square. We did not had a modulus, right? So you will not understand anything over here if you have not watched the previous video. So I do recommend watching it. So here if you see lambda into beta j mod, right? In this case it's not the square. So that is the mathematical difference between ridge and Lasso. In ridge you have beta j square, you have the square summations, but over here you have the modulus summation. And what was this beta j? This was nothing but this was the slope, right? Whenever we create y is equals to mx plus c, right? M is nothing but the slope. Now similarly, eventually I will re-explain this part as well from the previous video, that as part of linear regression what we are trying to do. We are trying to develop the best fit line, which is nothing but y is equals to mx plus c. Now if you have multiple input features, in that case your equation will become something like y is equals to c m1 x1 m2 x2 until the number of features you have. Now in case your c is 0, right? In case your c is 0, in that case your y will become m1 x1 m2 x2. Now in this case you can have 2.5 30 50. This is just an example. Now when you try to develop this particular y, right, and when your model runs, right, when your model runs, it will be computationally very expensive, because if you see for every value of x2 x3 and x1 it has to multiply by 2.5 30 and 50, which is a larger number. So to reduce the complexity of it, what we can do, we can actually add one penalty factor. That is what is called as penalty factor. 0.6 is the penalty factor over here, and you can see now the moment I include this point c over here, you can see that I have reduced 2.5 to 1.2, 30 to 2.5 and 50 to 5. Now this becomes a computationally efficient algorithm, and at the same time it also helps you in the conditions of overfitting. That is what we are trying to do. Now in case of your ridge algorithm, that 0.6 that I showed you over here was lambda into summation till m of beta j square, right? It was trying to do the square of your slope, but in this case it is trying to give you the modulus, right? That is the mathematical difference. Now Lasso is also called as L1 regularization. However, your ridge is called as L2 regularization. So these two are the regularization techniques that helps you in case of overfitting and underfitting situations, mostly in the overfitting situations. So now when you talk about this, right, there is one more thing that Lasso regression is helpful rather than your ridge algorithm. It is little more helpful in case of feature selection. So this is also used for the feature selection. Why? There is a very subtle difference between both of them. So now if you see, the moment I give you this particular equation of beta j modulus, right? Now when we have square, right, square of any number, right, and here you have a modulus of beta j. So in case there are any features, so in this case let's say if there is any feature in y is equals to mx plus c, if there is any feature x which has a negligible amount of influence in your output, right? In that case, the slope will be very less, right? The slope will be very less. Now, the moment that is very less, and if you do modulus over here, the whole factor becomes very less, right? But that is not the case of ridge, right? Because there you are trying to do the square. So in this case, the value of this coefficient can become 0. The value of this penalty factor can actually become 0 in case of lasso regression, but in case of ridge, it cannot become 0. It can go close to 0, but it cannot become 0 because there you are using slope square. There you are using beta j of square. But here you are using modulus. Now with this, what is the benefit? Now the benefit is, if you have, let's say, 5 features, right? Out of 5 features, if there is one feature which has a very negligible impact on the value of the output. So now in that case, this alpha, which is nothing but the hyperparameter, and we do hyperparameter tuning for this alpha, which we are going to cover in a separate video, this alpha into beta j becomes a very small value, right? Or it can also become 0. So this will help you to eliminate the not required or the less required features as well. So that is one of the very important features of the lasso regression, and I have also explained you how it is different than your ridge, right? So even if you look at this particular diagram, right, so your red line, if you see, that is the lasso regression line, and your green is the ridge, right? So lasso regression is trying to move a bit closer to your actual outputs, right? So this is what your lasso regression is all about. And remember that your L2 regularization is nothing but your ridge, and L1 regularization is nothing but lasso. What is regularization? I have already discussed in my previous videos as well. Now if you see, these two are nothing but the lasso regression algorithm formula and the ridge. So if you see this lasso, this is nothing but the cost function, right, which we have been learning in our linear regression videos. So 1 by 2m I to m, and then h theta x of I minus yi squared plus, this is the penalty factor, right, which we are adding. And why we are adding it? To eliminate the condition of overfitting in case of lasso and a ridge algorithm, and also to eliminate not much required features, or it helps you in the feature selection as well. So I hope you like this particular video, and do remember to like, share and subscribe. But always remember that especially in these ML videos, if you directly jump on to any one video randomly and you don't know any background, it will become very difficult for you guys. So it's always better to follow these videos in series. So thank you so much for being till here, and do let me know in the comment section what are your views on this series that I have, and thank you so much for being till here.